Okay. You guys are hilarious. Caitlin, are you going on the field trip with English people?
I did a full time for a summer internship and saved all my money.
Dude, your cortisol spike is so much. Dude, it's still better than not doing it
Okay,
at
also,
all. No, I'm making a joke about masters.
Okay.
I was gonna say it's still better than not.
So, Avery, I need to see your homework before the end of the hour because I didn't drink. You don't have it. Okay. Never mind. So we are skipping ahead to 7.7 because this is dumb. Like, this is truly an application of derivatives, and your book puts it in chapter 7 that we don't even cover. This is on the AP test, though. It's all over the AP test. This is one of the most helpful things that I will teach you, especially if you detest disguised derivatives. Okay? Nope, this one's good. This one's good. So I'm looking at Caleb because he's like, I hate these things. Okay? Disguised derivatives, you don't actually have to do them. Okay? So this is going to get you past that. So.
I don't even know if it's like doing the disguised derivative or realizing that it is a disguised derivative.
And Caleb, this will take care of that. Okay? So first of all, there's no S, right? There's no S in the middle of that. It's not hospital. Okay? This guy's French. So it's l'hôpital. L'hôpital. He's French. We're going to go back. This is just where we put this. Okay. So L'Hôpital's rule is a little bit of a weird place. L'Hôpital's rule is about limits. Okay, so L'Hôpital's rule is for limits. So you go, why didn't I learn that in the limit chapter? Because it has to do with derivatives. That's why. And when you don't know about derivatives, you can't learn about L'Hôpital's rule. So L'Hôpital's rule says if f of x and g of x are functions, and the limit, h of x is equal to f of x divided by g of x. Okay,
what does that say?
This is scribble.
Okay, that's just nothing.
The scribble. That says your teacher's writing in pen. That's what that says. Okay. And the limit as x approaches c, gotta make sure about that, of h of x. I'm going to translate this to English for you.
Why is it French?
Nope. It's very mathematical is all. Okay. Mm-hmm.
According to the exchange students, no one likes French people.
Okay.
I cracked a joke about it once, fully expecting them to call me any sort of name. They're like, no, you completely agree. French people suck. That's a lot of limitations.
No, I know.
This doesn't look easier.
I promise it is. As soon as I explain it to you, you're gonna be like, oh, okay. So the other thing, well, let's say this. So there's two conditions here. Okay. So the first condition is the translation here for you. The first condition is that you're dealing with a fraction. Okay. This is only used for a limit that is a fraction. Okay, so that's this piece right here that you're talking about an f of x divided by a g of x. Okay, that's the first thing. The second thing is that it is only works if we are talking about indeterminate forms. So the first time when you plug it in, the original answer, we'll call it the original answer is indeterminate. Okay, now remind yourself, what does indeterminate mean? Cannot be determined. It doesn't mean it doesn't exist. It just means it can't be determined. So let me get to my notes. Don't really have, by the way, because I know that you want to know these things. This section and one more, and then we're done with chapter 3. Okay, just so you know.
Was that supposed to say 3.7?
No.
We already went over
We did
that.
already go over this, bro.
It goes with chapter 3, but they throw it inside.
Yes, because the book is dumb. If I wrote a book, it would not be there, but I'm not writing a math book, so it's fine. Okay, so
Maybe you should.
indeterminate, I got to think about what ones we got to talk about here. There are many indeterminate forms. Okay, so I just want to take a side trip and talk about what things have we already talked about that are indeterminate.
Things over 0.
More specific. It's not anything over 0.
0 over 0.
0 over 0 is indeterminate. Before, when we've had 0 over 0, you've had to factor, you've had to expand, rationalize, or do the terrible fraction math, right? Those are the things that you have had options of doing. This is going to give you another option, okay? What else is indeterminate? What's the other indeterminate form we've talked about? 0 over 0 and? Infinity over infinity. And when you've had infinity over infinity, that's the one where you have to divide by the largest power in the denominator. That's probably still your best go-to, but maybe you don't want to do that. There's another option for you. There are actually like 6 or 7 different, didn't do that on purpose. 7 or 8 indeterminate forms. I will give you a couple of them that we might see. You could have, for example, infinity times 0.
That's the same thing.
It's not. Infinity times 0 is indeterminate. It's not always 0, which is weird, super weird. 1 to the infinity power is indeterminate. Usually we say 1 to any power is 1. 1 to the infinity power is not. Also bizarre. There's 1, 2, 3, 4. The other one that is fairly common is infinity minus infinity. Okay, that's not 0.
How is 1 to the infinity power not determinate?
I am just telling you the things that I know.
I didn't keep going far enough and then weird stuff like that.
You keep going far enough, weird stuff happens.
It just won't be 1 anymore. Yeah, so they'll just pop into 2.
These 2 are our primary that we will use most of the time, and you will see a little bit of infinity. You potentially could see those 4. Those are the most common ones. We're not dealing with anything with powers. So just to blow your mind a little bit, infinity to the 0 power, we always say like, hey, what's 3 to the 0 power? 1. Infinity to the 0 power is indeterminate. It's not 1. It could be something else. And that's because infinity is not a number, right? So what if I have a larger infinity and a smaller infinity on the top, larger on the top, smaller on the bottom, then it's not 1. Okay. 0 to the 0 power. We know that one is indeterminate.
Where does this relevate in actual life?
Caleb, you're in calculus class. We're beyond that. In my real life, I never have to know what an indeterminate form is. Okay, so it does.
So
Indeed.
use this?
I thought we
Talk to Joe.
Me?
Yeah, with your sister. Right? Or no?
She's in
She's
college.
not gonna have to use this in her work.
Okay, so
Yep, you're right. And we use derivatives in chem, don't we?
yeah.
Yeah. Like
I don't think
this.
we have to.
For tangent line stuff.
Yeah.
Except for some reason we find the tangent line to find the derivative, and I don't know how that maths, but.
Isn't it just backwards?
It's the same thing. It's because there's people in that class that don't know how to do derivatives. That's
Yeah,
why.
I think so. I think she gives us the tangent line because we don't.
Right. Okay, so been a while since we've done limits. Let me remind you,
You could teach derivatives in it.
Caleb, but yeah, if it's just the power rule, but it's not,
Oh,
right? Because of all the other derivative rules. What's the first step when you do any limit?
Check it.
Plug in the X value.
Plug in the x value. That would be your checking it. Yes, you're plugging the x value. So plug in the x value. What do you get?
0 to 0.
You get 0 over 0 because e to the 0 power is 1 and 1 minus 1 is 0. So we actually don't have another way to do this one. This is 0 over 0, which is indeterminate. Okay, but what I have here, let me pause. All the other times we've done this, we've had ways to actually get the answer. I'll show you some with ones that we've done in the past so that you can be like, oh yeah, this is better. This is indeterminate anyway, and it's a fraction, which means I can use L'Hopital's rule. L'Hopital's rule says, this is what this whole bottom thing is. If you have an indeterminate form and a fractional limit, then the original limit is equal to the limit of the two derivatives. Okay, so it's totally easy. What the difference here is that you write on your equal sign a little LHR. And that means that this is equal because of L'Hopital's rule. Okay, and I should have put it out here because LHR, limit as x approaches 0. You put that there because the thing that we're going to write down is not equal to the thing that's up here. Okay, like it's not the same limit unless you're applying L'Hopital's rule to it. Okay, so anyway, what's the derivative of the top? 2e to the 2x. Don't forget chain rule, right? E to the 2x is its own derivative, but times the derivative of the inside. What's the derivative of the bottom? 1. Now, plug in your answer. Or plug in your 0 now. What do you get? You get 2. Correct. And you're done. So L'Hopital's rule gives you a way to do limits that were previously undoable. No. What this does give us, like let's say we are going to do something like this one. Limit as x approaches 2. Oh geez.
Would you have to do something like negative quotient with L'Hopital?
No, I don't even know how you would do that without L'Hopital's rule.
You just have to do it equals to, like that's where how you show your work. You didn't have to drop that too.
No,
Okay.
done. Because that's the answer. I plugged in the 0 and got 2. Done.
Okay.
I will show you the other ones in a minute. I can't do it yet. So let's do this one. Let's say we have the limit as x approaches 0 of sine of 5x over 2x. So I want you to make sure that you understand there's nothing about this that will actually flat out say, use L'Hopital's rule. It's the two combinations of when you plug in, you get indeterminate 0 over 0 or infinity over infinity, and it's a fraction. Okay? Those are the two things that will say, hey, I can use L'Hopital's rule.
On the test, will they ever have limits that you plug in the value and it just gives you the straight answer, or will you always have to do something with it?
I'm sure that there are limits that you'll just plug in and you'll get the answer.
Because
I would not plan on a lot of them because it's easy. Yeah. Yeah.
Well, every test has a gimme question or two. Like
Correct.
Standardized.
Right. So, first of all, do you get 0 over 0?
Yes.
Okay, so the one thing that's different about this than the other way that you do it, you do need to say that this is indeterminate. Okay, because that's the condition upon which you can start using L'Hopital's rule. It has to be indeterminate. So you got to at least say this, okay, that it's indeterminate.
You have to actually write indeterminate. You can't just write 0 over 0.
Correct. Okay, so we're going to use L'Hopital's rule. Aiden, it's 5 letters. Get over it.
I just said that. I was like, dang it, 5 letters.
Mm-hmm. Okay, so we're going to use L'Hopital's rule. So put the LHR there with your equal sign. And then what's the derivative of the top?
5 cosine 5.
5 cosine 5x. That's chain rule again. People, right? Derivative of the outside, don't touch the inside. So cosine 5x times the derivative of the inside. What's the derivative of the bottom?
2.
Okay, now plug it in, see what happens. Yeah, it's 5 over 2 because the cosine of 0 is 0. I'm highly recommending that you remember what those graphs look like.
Yeah, they're gonna.
The cosine of 0 is not 0, it's 1.
It's okay.
I was like, wait, that does not math.
They're gonna give us these with no calculator, right?
Yes. But this is 5 over 2. We did not have a way to do this before because this doesn't hit any of the rules that I already taught you. Okay, now,
Why are we learning this now?
I already said
I
this.
know, no, I know you explained it earlier. This is what I'm saying. We just went through a lesson of completely different things.
Okay, because the whole chapter, the chapter itself is on applications of derivatives. Like, what could I actually use a derivative
Is
for?
that what we're doing here or what we did?
This is, well, L'Hopital's rule is a way to use derivatives to do a limit problem. Okay, so we're going back to limits, but because derivatives are involved, it's here. I don't know if that's the best answer, but that's what I got. Okay, now let's do let's go back to ones that we would have done like in the chapter 1. So all the way back to chapter 1. So let's say we have x squared plus 2x minus 3 over x squared plus 5x minus 6. Now, I'll tell you the other reason that I like this is because the notation is a lot easier. So we had many arguments, friendly discussions over where you're going to put your work, how you're going to write your work, how many equal signs you need, and blah, blah, blah. This helps that, my personal opinion. What do you get when you plug in the 1?
0.
Over? 0. You get 0 over 0, which is indeterminate. Now, I'm going to tell you, this is a tidbit I learned from grading. They do not like you to put an equal sign there because something cannot be equal to indeterminate, right? If you can't determine something, you can't be like, hey, that's equal to can't be determined. It does not make logical sense. So that's why I'm using an arrow there. Yeah.
Can we equal does not exist?
You can equal does not exist. You probably should arrow does not exist, but
So if we do arrow, we're safe on all fronts.
Here we go.
unless it's actually a number. Yeah. Okay, so we can apply L'Hopital's rule because it's 0 over 0 and it's a fraction. Now, I want to remind you before we would have had to been factoring everything. This is also good for people who are not super fast factorers. Okay, no judgment intended at all. What's the derivative of the top?
2x plus 2.
Okay, what's the derivative of the bottom?
2x plus 5.
Okay. And then plug it in. What do you get?
4 over 7.
4 over 7, and you're done.
Doing the derivative, right?
What?
Doing the derivative, right?
Okay, so listen, that's a good question because if you look at what I wrote down for L'Hopital's rule,
It's f prime of x.
it's the derivative of the top over the derivative of the bottom, not h prime, which is the fraction itself, but the derivative of the top, derivative of the bottom. So this is not good question. This is not a replacement for quotient rule. Quotient rule is straight up for derivatives. This is for limits. Okay, and it's its own thing, derivative of the top,
But
derivative of the
if there
bottom.
was one where it was like
A double fraction, you could still have to use quotient rule.
Oh heavens, but yes, that would be terrible, but yes.
That's what, like, an extra credit you gave us was like that.
Yes, so let's talk about that. We'll talk about that in a second. Let's do this. You can't see anything. There you go.
I heard
Um,
Polish daughter, so
Oh, yes, bro. If it's a Polish dog, I will rejoice.
I'm I think there's hot dog is better than Polish dog.
Yeah, that's
Hot dog is better than
Thank
Polish
you
dog.
for saying he doesn't like to sleep.
That's
Polish
crazy.
dog is
That's
gonna be
really
fun.
fun.
Try them side by side. Hot dog is gonna be better.
Jason probably also thinks.
So it's also more baked. Whereas.
I mean, that's
This a 2.
Ms. Douglas, I have a not related math question.
Yeah.
Can I ask you real quick? Has anyone been to the hot dog place in town?
There's a hot dog place in
There is.
You haven't tried it yet? It's
It's
actually
kind of
fire.
expensive.
Is it new?
But it's cheap for lunch.
There you go.
What about it? My dad really wants to go. I don't like the hot dog.
Okay, so
Just because of how they're made, I don't know how.
no. Okay, I don't like them either, but we don't want to talk about it. Okay, so listen, the nice thing about this is then a problem like this gives you another option. So up till now, hopefully you would recognize this as a disguised derivative problem. Okay, but if you plug the 0 in, I bet I screwed it up just a second. In fact, I know I did. 4 minus 2. Okay, let's try that. Nope.
What?
Minus 2. Okay, there you go.
That's why I waited to write it.
Mm-hmm. The minus 2. Okay. If this is wrong, I'm gonna throw my marker is what's gonna happen. Okay. What happens when you plug in 0? You get 0 over 0. So you don't have to. Like if you're like, I really struggled to do those disguised derivative problems and to find the correct thing, you don't have to anymore. You can use L'Hopital's rule because this is 0 over 0.
It's just an easy chain rule.
It's an easy chain rule. Correct. So L'Hopital's rule says do the derivative of the top. Hang on, let me write it down. There we go. So what's the derivative of this? Times 2 plus h. But the derivative of the inside is 1. That's what Joe's talking about by being an easy, that's an easy chain rule. Okay, I've got minus. What's the derivative of the next bit in there? What's the derivative of that? Just 1.
Oh, I thought it was also.
No, there's no exponent, right. And then what's the derivative of 2? 0. And then what's the derivative of h? Plug in the 0.
So they'll know that we're talking about the rule as long as we write LHR.
That's why you do it. Yep. So I think it's 3.
Yeah.
So remember before when we were doing this with disguised derivatives, which is fine if you're like, I don't want to do it this way. Okay. Remember then that this is the equation x squared minus 2x. And then you're looking for f prime of, I'm sorry, it's x squared minus x. And you're looking for f prime of 2. You can do it that way still. This one works all the time, though, in all of the situations. So if you remember, you might not remember, disguised derivatives, when we talked about that, there were a couple people that were like, what do I even do with that? I don't even need to know what that's. Do you know why you don't need to know what that is? Because eventually you're talking about the fact that you're doing derivatives, and the derivative of any constant is 0.
So every time one of those pop up and it doesn't specifically say to use the disguised derivative, we can just do it like that.
Absolutely.
Will it ever ask-
It will never tell you to do disguised derivative.
I thought the whole point was they like make you remember what to do. Like they'll ask
But there's options.
Yeah.
All this means is there's options.
Yeah, no,
So
that's what I mean. Like they wouldn't give you one. They want
Nope.
you to remember what one you could use.
what you could use. Yep.
I don't really remember any